of the natural log function. What's the derivative of the natural log of x? 1 over x. What's the derivative of the natural log of u? Yeah, u primed over u, or 1 over u times u prime. Same thing. Okay, or you could write it as 1 over u du dx. All the same thing. Basically chain rule, right? Okay, so what's the integral of 1 over x? ln of x. You're going backwards. ln of x plus c, actually. Can you log a negative number? Can't log a negative number, so should technically have an absolute value there. Okay? You cannot log a negative number. It's illegal, a negative number. Like log of negative 2, you can't do. Okay, now you'll see this is going to look a little weird for a sec, but I'm going to show you how it connects. What's the integral of u primed over u? It's ln of u. That's right. I mean, I guess it's not that weird. It'd be absolute value of u because u cannot be negative. But basically, it's this, right? You're going back. So it's the exact same thing. Oh, sorry, plus c. Yes. Thank you. Okay, so your goal when you're doing integrals is to, and it's not, sometimes it'll be obvious that this is going to be a natural log. It won't always be obvious from the original question, but your goal is to make it look like that or like this. Usually like this, and it'll be a u in here. It'll be like 1 over u, okay? And when you see 1 over u, you know it's the natural log integral. All right? Yeah.
So it's derived to d for the second one, not the
Yeah, it'd be the integral with du. I know it looks. Yeah, it is du. Yeah, I'll show you how this one ties out. This is the one we're going to use most of the time, but I'll show you how you can use this. This is more like when you look at it initially, you can get the answer quickly if you start to recognize it. Okay, and I'll show you an example of that in a sec. All right. Okay, we're just gonna do a bunch of examples. So, example number 1. We'll start basic. All right, what do we do? Yeah. So you can pull the 2 out. Then you have that. What is the answer to that? Two natural log of x plus c, right? Okay. Now what you can't do is you can't do this. You can't do that and then try to add 1 to it, right? Because if you're doing the add 1, you're going to get add 1 to it. You're going to get x to the 0, and then you're going to try and divide by that new exponent, and everything goes blah, right? And that's why it has to be a natural log. When it's x to the power of 1 in the denominator, it's going to be a natural log. Okay. Integral 1 over 4x minus 1 dx. Okay, I'm going to show you 2 ways to do this one. What's the first thing? Sorry, what do you want to do? But then you're gonna run into the problem that we did up here where we tried to do add 1 to the exponent and stuff. So you're gonna have to do a u substitution. The only thing u can be is 4x minus 1. So if you go u is equal to 4x minus 1, du is equal to 4 dx. So that means du over 4 is equal to dx. So then this integral becomes 1 over u du over 4. The 1 over 4 I don't really care about. That's just a constant, right? So what's the integral of 1 over u? It's going to match this one, okay? It's going to be natural log of u. So I'm going to get plus c, what was u? Four x minus 1 plus c. That makes sense? Okay. Here's a fast way. When you get good at this, this is how you can do this. So see this formula right here? U primed over u. If you have the derivative of the denominator sitting in the numerator, you know it's going to be the natural log of whatever the denominator is. That's what this says, right? Because u prime is the derivative of u. So if it's sitting up there, you can go straight to here. So if I look at this function, 4x minus 1 dx. What's the derivative of the denominator? 4, right? So if I had a 4 in the numerator, it matches that u primed over u. Can I put a 4 in the numerator? But you have to do what? Yes. So what you can do, you can put a 4 there, as long as you put a quarter out there, right? Because that's really just 1. Does everybody agree with that? Okay. This is u primed. That is u. It'll be faster because you don't have to do the u substitution. Look, you can do u substitution every single time. Just do that. It'll work. But when you get better, you can do this. So when you do enough of them. So I can put a 4 there as long as I put a quarter there. Now we have u primed over u, right? Which is this formula right here. So it's just the natural log of whatever the denominator is. So it just becomes the natural log 4x minus 1. The 1 quarter sits outside. Tack on a plus c and you're done. So the more you do, the faster you'll be able to do this kind of stuff. If you don't like that stuff, do u sub every single time. Okay? And u sub's going to be the more common method that we use. All right, so let's look at the next one. We'll do it 2 different ways in the next one. Integral 3x squared over 1 x cubed over x. All right, let's try look at the denominator. What's the derivative of the denominator? Just do it quickly in your head. 3x squared plus 1. Does that match the numerator? It does, right? So if you're thinking that's u, then that's u primed, which matches our formula. So the answer should be, I'll do it the long way in a sec, the natural log of the denominator, which is x cubed plus x. And you're done. Okay? If you don't like that, what you can do, you do u sub. You go u is equal to x cubed plus x. So du is equal to 3x squared plus 1 times dx. So the integral becomes 1 over u du, which is, well, when you put it back in, you get that. Is that okay? All right. You ready for this? Nobody likes trig. Okay. We'll do u sub. Okay. What are you going to make u?
10. Because 10
So I'm going to go u is equal to tan of x. Du is going to be the derivative of tan is secant squared of x dx. So this integral now becomes the integral of 1 over u du, which is the natural log of u, which is the natural log of the absolute value of tan of x plus c. Could have done that directly from the beginning if you saw that that is u. If this is u primed, and this would be u. So it matches that pattern. Okay. Another one? I'll let you try this on your own. You ready? One half natural log of the absolute value of x squared plus x. Yeah? Yes. So the other way is the shortcut. If you did the shortcut, you look at the bottom. What's the derivative of the bottom? 2x plus 2, which is really close to that, right? So if I just put a 2 like that, but then obviously you have to put a half there, then it matches your pattern because you have u primed over u. So it's just 1/2 natural log. And you're done. So if you see the pattern, it makes it really quick. You don't have to. U sub works fine. Now, my question is, do I need the absolute value?
No. Yes. No, maybe.
You say maybe?
You're cutting a face for every answer that we give. So.
Okay, so if I put a whole number, a number bigger than 1, so like -4, right? Is that going to be negative?
Yes.
It's negative 4.
It's going to be positive.
Oh, it's -4. Sorry. So I'm going to get 16 minus 8. That's going to be positive. So they always going to be positive?
No, it's not.
Yeah. Or if you put, so let's put -1/2 in. Negative a half is, squared is 1/4. What's 2 times negative a half? Negative 1. Is that going to be negative or positive? Negative, so you need the absolute value. The only time you won't is if you have even exponents on both. And I won't say the only time, but if you have even exponents on both of the x's, then it's always going to be positive, right? Okay. You can just take off the absolute value. But, oh, it'll be fine. But I know that in Math 100, if you leave the absolute value there when you don't need it, the prof will take off a mark. So just be aware when you go on, that's something that they're going to look at. Okay, so be careful. Okay. Like if you had the natural log of x to the 4th plus x squared, that would always be positive. You can just look at it and just kind of be like, test some points. But I don't care too much about that. But and I don't know if all profs will care, but the one that they have this year does. Okay. Okay. Oh, you're gonna love this one, peoples. It's gonna be your favorite. I'm gonna show you two different ways to do this one. So integral. Maybe 3 different ways. Is it 6? Let's go with 7. I like 7. Okay, 7 minus 1. How's that? All right. What do we want to do? Why are you laughing? All right, what should we do? Any ideas? Factor. We try and factor the top. Top doesn't factor.
Use sub.
Well, okay, what are we going to use sub?
The numerator.
The numerator?
Never mind, no.
I'm just asking.
No, I just realized.
Okay, so we can't factor. The top doesn't factor. What?
No, never mind. That's just gonna get complicated.
What did you say?
Dina said it. Dina should say it.
Maybe you're right.
Break it apart.
Okay, how do you want to split it apart? So, say that again. What? You can.
Break it apart factor.
It doesn't. The top doesn't factor nicely. But the one thing you do know how to do is divide polynomials. So we can divide it. This is one way to do it. I'll show you another way to do it. So you can divide. Okay. So we can go, okay, it's x squared plus 1. We'll do long division. Does anybody remember synthetic?
Yeah.
You can't do synthetic here because it's a nonlinear denominator. Okay. So x squared plus x plus 1. Okay. So what do we do here? Do you remember how to do this? Okay. So we ask ourselves, all we care about is the x squared. We're looking at the x squared. What do I multiply x squared by to get into x squared? 1. And then I multiply that 1 into there. So I go 1 times x squared is x squared. 1 times 1 is 1. I'm going to line it up with the other 1. Okay? And then you subtract them. X squared minus x squared. X minus nothing is x. 1 minus 1 is 0. Okay. So this is my remainder, right? This is the divisor, and this one up here is the quotient. Do you remember how we write things in calculus? We did it when we did limits to infinity. Yeah. Q plus R over D. Okay. That's grade 12. So you're right, q. So it becomes the integral of q, which is 1, plus the remainder over the divisor. Why is this a good thing? So you can break up the integrals, right? What's the integral of 1? Just x, right? What about this one? Okay, so we can use the pattern recognition. You seem very excited, Isabella. What's the derivative of the bottom? 2x. So if I had a 2 there, we'd be very happy, right? But you have to put a 1/2 out front. So what's the integral of the second one? That's u primed. That's u, so it should be? And the 1/2 should be out front. And then we should put a plus c. Is that the absolute perfect? If you were in Math 100, you would get 100% of your marks? Why is it not? Do you need the absolute value? Well, x squared is always going to be positive, and then you're adding 1 to that number, so it'll never be negative, right? So look, in my class, you can leave it like that. That's fine. But just be aware that some profs will care, so we will write x 1/2. Is that. Okay? So I'm going to show you another way to do this question. If you don't like long division, there's another way to do it. You just don't like any of it? Okay. So you can rearrange this without doing division. Okay? Watch. I can take that, okay, and I can rewrite this integral as x squared plus 1 plus x over x squared plus 1. All right? Yes? Okay. Now what I can do is I can be like, oh, look, the x squared plus 1, the x squared plus 1. If I could write those as over top of one another, they would just disappear to 1, right? So I can do this. You can break it apart, but you got to be careful. Is that the same thing? It is, right? Because if you have the same denominator, you just add the numerators, which is doing this. Okay? X squared plus 1 over x squared plus 1 is? Plus the integral of x over x squared plus 1, which is what we had right there. So that's a trick, right? If you see things, you can manipulate this. And I've always told you, you can't break it up unless you have a single denominator. You actually can, as long as that denominator goes to everything that is in the numerator. Okay? So if you're careful about how you do it, you can simplify things and then integrate them. Okay? These are all like tricks that'll help you. All right, let's do one more. What do we want to do? What are we on? Number 8 now? 7? No, I think we're on G. G. Needs a last one for the day. Last one for the week. Holiday Monday, peoples. All right. What do we do? What's the derivative of the bottom?
Oh,
Let's square. It would be like drop the 2 down times x plus 1 times times an inside derivative of 1. It would be 2x plus 2, right?
Yeah.
Yeah,
Yeah,
because
because
like
you
the 2,
multiply it.
I'll write it. Just so we can see it. If you did the derivative of the bottom, you're going to get 2 times x plus 1 to the power of 1 times the inside derivative, which is 1. So then you can multiply that in and get 2x plus 2. Does that show up in the numerator? No. So does that help you? You might be able to work around da 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 da. Do you have another idea? Move it up? That's not going to help you too much when you're trying to integrate it. When you're doing derivatives, yes, because then you can use product rule, but not when you're doing derivatives. So I would just do u substitution. Oh,
So if we multiply x plus 1 twice, like,
Mhm.
like.
Wrote it out as x plus 1, x plus.
Yeah,
Oh, expand it, you mean?
expand it and then divide it, like x plus, divided by x squared, like that. Like, exactly.
So
what we
you-
did
you-
last time.
But there's only one term up at the top. Like so you'd want 2x, you'd want this.
Yeah.
And then,
Yeah.
but how are you going to expand that? Like, because you only have one term here, right? Now,
Wouldn't that be like 1 over x squared plus 1 plus 1? Or like.
what?
I mean, there's like invisible ones on the top.
So you want to start going plus 1 minus 1? What do you, is that what you-
No, like 1 multiplied by 2x is like, there's like an invisible 1 over there, isn't it? Like there's almost like
here?
Yeah.
Yeah, okay.
I was like planning on like doing like 2x over 2x and 1 over x squared and 1 over.
Oh, you can only do, like,
Yeah.
it'd have to be addition for that to work. So yeah, no, is the short answer for that. I think there's a workaround that you could do, but it's probably more work than we want to do. So u sub is valid. Let's do u sub, okay? What is u going to be? X plus 1. So du is equal to dx. Yeah, is that where we are? So we put that into the integral. We get 2 x dx is du. So I get over u squared du. So I end up with that integral. Oh, you're right. Wow, I totally messed up. So the x is still there. That's my problem, right? So x is equal to u minus 1. Thank you, Vina. I'm making a lot of mistakes today. So x is equal to u minus 1. So u minus 1. There we go. Everybody with me on that? Yeah? Okay. I'm going to pull the 2 out just because I don't want to deal with it. So I have that integral. What do you want to do with that? I would break it apart now because you have a single denominator. So then you're going to get 2 times the integral. U over u squared is 1 over u minus 1 over u squared. So the other one's just going to be a regular one. So we're going to write it as 2 times the integral of 1 over u plus the integral of u to the negative 2. And it should be minus is what it should be. Like that. So now you can, and they should have du's, but whatever. So now you can integrate it. The first one, 1 over u becomes 2 natural log of u. The second one, you're just going to add 1 to the exponent and then divide by that negative 1, right? So we're going to add 1 to this, which is negative 1, divide by negative 1, which is going to cancel that. So it should be a plus u to the minus 1. So we're going to put our u's back in and then add the plus c at the end. What was u? I don't even remember. X plus 1. So we get 2 plus, I'm going to write this as 1 over x plus 1 plus c. And it's 2 times both of those. Boom. You could put the 2 into both of them if you wanted. Does that make sense? So, u substitution, pattern recognition, if you see it right away, if you have like these ones where you can make u primed over u, that makes it really fast. And if it's really gross, you can divide it, polynomial division, or you could rewrite it by kind of rearranging the numerator if you want and breaking it up, depending on what you want to do. Or straight up u sub. Okay. Any questions? Page 334, 15, 21, 23, and 25. Please. And that will bring